The end is near. There's just the annoying fact left that I can't really reach my buttons when the lid is closed. And I can somehow, you saw it in the last video, but yeah, I want to see my display without any hassle. And of course, from the software review for the controller, there were also some, let's say, flaws left and a real bug. So let's first get that software stuff out of the way. I'll try to keep it brief. I will dive into the software now, and I promised I will try to keep it brief, but if you haven't seen the review of the controller software card link, this makes no sense for you. Use the time index in the description down below to skip the whole thing. Or when you're not interested in that software stuff altogether, then also use the time index to skip that part of the video. So nothing much happened in the declaration, but, and this is a flaw, I added actually a type to my enum states. Yeah, I boosted about you should use enum instead of define statements for such things, and then I didn't declare the type. Well, shit happens. The other thing that is more important, I changed the names of my state variables. These were initially requested for ask status and run status, and yeah, reviewing the video and cutting it, I noticed that always saying the run status is now set to status run. Yeah, it's clearer that way. Yeah. Another, I call it flaw, was actually in the loop function, where I used the millis to determine when to call my update display and timer function, every 500 milliseconds, that is. And in theory, I think I talked about it. In theory, millis here and millis here could differ by 1 millisecond. There is a certain probability for that, and it's probably very low, but it can happen. And I said, yeah, I don't care about a millisecond, but that statement for the full runtime of 600 seconds or 599 seconds, which what I can say, let's say 600 seconds, it's called 1200 times. And that translates to a worst case error of 1.2 seconds. And yeah, you wouldn't want to have that kind of code in your rocket, would you? So why should you have it in your UV exposure unit? So there's a little change here. I'm still using millis. I rearranged the if statement here a little bit. And this is an additional line that sets my last display and timer update if it is equal to 0. That is, if we enter this the very first time, 2 millis. So I first sync it up the first time I enter here with the millis. And after that, I'm just, each time I enter the body of the if statement, I increase my last display and timer update by 500 milliseconds. That way, yeah, it will increment fixed by 500 milliseconds and no millisecond will get lost. Yeah, was just a flaw. I did some cosmetics in the keypad event function. That is, I replaced here these bracket condition, bracket question mark, expression, colon, expression statements to determine if I am allowed to decrease or increase a value, that is my time set and my digit edited. I replaced that because it's for readability by a real if statement. So if digited edited is still greater 0, then digit edited decremented by 1. If digit edited is less than 2, then digit edited incremented by 1. Yeah, just cosmetics, and here for the timer variable, yeah, it's the same. Also, I think I used here initially something like greater or equal 1 and below smaller or equal than 1, which is 1, 1, and now you have 0, 2. Makes it a lot nicer to read and to understand. The real bug was in the, that's the overview, we will dive in the update display and timer routine. And you remember that has 3 sections basically. One section handled state changes and timing. The other section handled the current state, or back then we called it the run state, and timing. And the last micro section just toggled intermediate. And the flaw, or no, real bug, was actually here in the state changes and timing section. At the end of the actual or run state, now current state handling section, if the status was run and we were on a full second, we always incremented the timer. So when the function is exited, the timer is on the full second always already incremented. And without any thought, when we were in the state change section and we are in the status run and we switch to the status stop and we are on the full second, then we increment the time again. That makes absolutely no sense. Same here for pause. If we are on the full second, we increment the time again. So depending on when you click the buttons, press the buttons, we're not on a touch screen, or using a mouse, we have a double increment in time. That's a real bug. And the flaw is that depending on when we are pressing the buttons, we might lose half a second. That's because I only handle full seconds here. And further down, when we are in the status pause, we had, yeah, that's neither a bug nor a flaw, that's simply ugly. We had that exception handling when we go from pause to run again, and our time has already elapsed. So we had a whole section here doing some exception handling in that case. I didn't like that either. So that's the overview of the new code. Yeah, I will dive in a second. Yeah, and it looks a little bit bigger, but actually if you compare it, I used a bigger font to print it out. So all in all, the routine got even shorter, which is always a good thing. So we have a completely new section at the top, and I should use blue for that, like last time. That section up here is handling the timing. And the timing only. That section here, that's our state change section. That handles state changes. And state changes only. And finally, the last two sections, okay, very last one with the toggle, that's completely unchanged. And yeah, this section here, which actually handles the actual state, the current state, that was a wee bit restructured and got shorter. Both sections got shorter because they were really only handling one thing: state changes and current state. All the timing stuff here and the exception handling disappeared. So first of all, I introduced an extra variable, time intermediate. I think no, time elapsed was time elapsed. Time intermediate, which basically counts half seconds in addition to our integer time elapsed. And this is now the routine that handles all of the timing stuff. So if our current status is run, then our time intermediate half second flag will be synced to the intermediate. Yeah, we are calling that function every half second, and to remember, on each call that intermediate flag here will be toggled between true and false. If we are not in the intermediate state, then we increment our time elapsed by 1 second. And if time elapsed by then has reached the time set, then we request a status of stop from the sections below. So, and that's all. That's all the handling of the timing in one place at the very start. So instead of incrementing the time somewhere down below, we know if we enter this function, time has elapsed. And are in the run state, of course, time has elapsed. And we are now in the part that handles state changes. So yeah, if requested status is equal current status, is not equal current status, then depending on the current status, for example, status stop, we go to, if the requested status is run, to run. And this is pretty much the same, but for all that timer handling. That doesn't happen here anymore. Yeah, because that has already happened. And the only interesting thing here is when we go from status pause back to status run, we synchronize our intermediate with time intermediate, that half-second timer. And therefore, we are now really, on time exactly when we go from pause back to run. Also, that's further down, further down. Yeah, and the whole section handling the current state, that basically collapsed to not even a full page in big letters. Of course, it doesn't have to handle the timing anymore. That's an advantage. And secondly, which also made the code much more readable, to compare it to the old version, there I switched on the case, on the status, and then I have an if-else statement switching on the intermediate flag. And I basically reversed that. So my outside is now the if-else statement doing the intermediate or not intermediate stuff. And inside I have the switch statement on the current status. And that's really easy because if we are not in the intermediate state, we have, depending on in which status we are, just a lot of OLED print time statements. Okay, that's all what we have to do for the current state. Basically, this almost, not almost, this does collapse to handling display updates in the current state, the whole section. And if we are in the intermediate state, status run and status pause, the same, we clear something in the display to create a blinking effect. And case stop is a little bit more complicated because we have to check if the time in the EEPROM is equal to the set time and blink an additional colon in the set time, besides the digit we are currently editing. Yeah, and that's it. That's the improved code. Now back to the mechanical stuff. Now to the problem that can't be solved with dabbling a little bit on a keyboard and uploading a new code. I need to get to my keys. And the idea here is I cut the stuff out here. So I will, the outermost ribs, I will let them be for now. And I will cut out the rest. To do that, I start here in the corners with drilling 2 holes as big as possible. So I have here a little radius. It will look much cleaner than trying to work in that tiny little corner here. And with the holes being drilled, it's time for the Dremel to make the rough cut. So this time I set up a fence for the cutting, so I don't go too deep. And also the workpiece is secured, so I can guide it with 2 hands. That should be a bonus, I hope. The problem is that with my cutting blade I can't really cut through because I'm not getting deep enough. That's a bummer. So no, there's no way that with that small cutting blade I can get through, which is a bummer. So the question is, taking a bigger cutting blade? Is there such a thing? Problems, problems, problems. Yes, indeed. You can get bigger cutting blades, for example on eBay. Much bigger cutting blades. This is not original manufacturer equipment, yeah, I'm wearing glasses, just, you know, in case. And I adjusted the fans because also, yeah, there's a slight difference here, and yeah, let's see what happens. Should be big enough to cut through this time, at least. Don't know if you can see that, but yeah, we are sorry, we are through. I see a lot of work with the file coming up for me, or something like that. We'll see. Okay, I guess the rest I do with a normal saw blade. It's not that much left. Okay, in hindsight, the problem here is that the plastic melts when you go in with a blade at 5000 RPM. It gets so hot that it melts and clunks up everything. So again, in hindsight, it would have been easier to do two big holes or one big hole somewhere and then to saw everything, because that just went through it like butter. Okay, I think I will refrain from using 5000 or more RPMs on the stuff and file the rest by hand. So let me get that turned around and clean up a little bit. So I cleaned up, gave everything, especially the glass plate, another wipe with alcohol. And now if we close the lid, yeah, a little nick. The edges are not quite up to where I wanted them to be, but yeah, looks good. Well, looks okay, not good. I admit it, looks okay, but yeah. Anyway, that was my UV exposure unit build. And yeah, it's finished. I mean, I have some ideas how to improve it. For example, we could have several programs. I mean, I have a big enough keypad to do that. And yeah, of course, I could always add more UV LED boards to expose bigger boards, but I have not the need for either right now. So let's just say bye.